This conference will now be recorded.
Okay. Hello. Good afternoon. I would like welcome you on today's session. It will be focused on digital twins for agriculture, about the future ideas, how we can integrate it, different technology into some good Earth model. We have on the end I think 9 or 10 presentation, because one presentation was cancelled. Unfortunately, Maxar was not able to do a presentation, so we have 2 sessions, and we will start now with the first. First will be my presentation. It will be such introduction, and I think that most of other presentation will be technical. This first presentation will be non-technical, and I will speak about some white paper and vision of projects L4Agri about the future. This white paper we are publishing this week, so this is in reality first presentation of these ideas of this white paper. Okay, at first, if we are discussing about agriculture, we have to say that agriculture is now under the some influence of some different drivers, and these drivers probably will more and more stronger influence the agriculture in the future. We can recognize the question of food safety, food security. There is the quality of the food, the demand on the production of bioenergy, influence of politicians and other. And it is important to improve future knowledge management to be able to solve. Now, I think I have to mention 2 most important could be political initiative or document which will also strongly influence agriculture. It is European Green Deal agenda. You can see here the topics of European Green Deal agenda, and it is not only this farm to fork which will have influence on future agriculture, but it is a question of the biodiversity, is a question of the climate, zero pollution Europe. So many from this aspect will influence agriculture in future. If we will not stay only in Europe, on the global, we have sustainable development goals, and also here you can see the number of topics which will influence very strongly future agriculture, and it is necessary to say that to be possible fulfill all this issue will be necessary to have strong cooperation and to build new and future model. And I will now try to explain what is the topic of our white paper and what are some main results from this white paper. So if we will simplify all these things, we can say that future agriculture production will need to be in future globally increase because the number of population is growing. We need to make higher quality and using less land because we are all time losing the land, and also fewer inputs like chemicals, but also fuel and other. So this is not easy task, and only the way is to be able to improve knowledge management in agriculture. And knowledge management, as is understand, is to moving from the data to some final wisdom where we will have some idea what we can do with agriculture. In L4Agri, we look on 4 different sectors or 4 different parts which are related to agriculture. It is farmer, not only farmer, but it is all commercial sector, agro industry, but financial sector. The question of global food security, and because we are in Europe, common agriculture policy implementation. Now I will move a little more to agri-industry sector, and I think that I would like ask all to look on this image, because I think that this image is very important and can explain or can give answer on many things, or also eventually many problems of different platforms. Now very often it's required build some marketplace, sell some application for farmers, but I know only few farmers who are able, for example, to start from satellite images and to prepare recommendation. I think that in Czech Republic could be 3-4 such farmers. Yes, and I am sure that in other countries it is not better. So all this is some chain, and it requires some cooperation of many players to start from the data and to prepare some final recommendation for the farmer. I am sure that almost no farmer will go to some marketplace and will download there some apps which will solve one concrete problem and not working in the relation with others. So this is something what I see as very important. Now I would like to mention also food industry, because it is important. It is taking the result of farm production, and it is processing from this food. What is here very important, that already some food producer start to cooperate with farmer and build advisory system for farmers to help them with precision farming and to enter this chain, which was on a previous image as one from the player, and help farmers to optimize their production. It is mainly for such food producer who need high level quality of products. I know such examples like, for example, Barilla or Neste, who are offering such services for farmer. In the Czech is thinking about this Pilsner brewery, also to support the supplier. So now we will go in this line from the data to knowledge into the first topic, and because EO4Agri is mainly focused on Earth observation, there are 3 types of data. Of course, we are mainly working with satellite data, but useful could be aerial data, including drones, and of course more and more important are in situ data. Here is one very interesting result of analysis which we done in the questionnaire, and this can generate some troubles for us for the future. If we are looking on the farming sector, it is not the case of Czech Republic, but in other country, the big part of farmers is working on the farms smaller than 5 hectares. So if they or their consultant want to use, for example, Earth observation data, they need very often the data with better resolution than is current Copernicus or current Landsat, which are open, and usually this quality of the data is only supplied by commercial supplier. But on other side, if we look and ask farmers or their supplier about willingness, or not only willingness, but also sometimes about the possibility to pay for such services, then we recognize that the most of farmers is not able or not willing to pay more than 5 euros per hectare. Yes, and so it could a little reduce optimism of many system developers, because if we are able taking this soon, we are able to calculate the maximum cost which are farmers able to pay in 1 year, for example, in Czech Republic, and this could give us some estimation what we can in future expect it. So, some conclusion from the data. The data are important for future agriculture to improve this. I mentioned that farmers are looking for higher resolution, but the possibility to pay are minimal. So there is important to look on the way how we can share this cost, or how we can find the way that this cost could be in some way reduced, because it will be important if some services will require this data, then it will be necessary. Of course, what is also important to be able to combine this data with other data. Next step, information. There exists number of delivery platforms which has to go to deliver data which are later used for the analysis and preparing recommendation for farmers. In Europe now we have the DIAS platform. There is currently 5 DIAS platforms, but this is not only. There is some requirement that this DIAS has to be after 2022 self-sustainable, but on other side there are some obligation to offer open access to the data. Here I put some number of other data delivery platform. I'm sure that there is not all that I miss some, but the important is that there is number of data delivery platform, and we can look on this different possibilities. Some are open, some are paid, and if we spoke about the data difference, then it could be visible satellite. There are important meteorological data which are very important. There are now systems which are offered access to the data from a machinery. For example, Data Connect is trying to uniform the data from different producer, or AgroLink, it is the system coming from ECHO. What unfortunately is not till now well delivered, or is delivered only through commercial and proprietary platform are could be agrometeorological and this type of data, because there exists number of producers like PESEL and other, but all data are in different using different protocols, and this is in some way limiting access to this data. So we have a number of delivery platforms, and the question is in Europe if this DIAS platform, all 5 DIAS platform will be able to sustain after this 2022, when we'll finish the support from European Commission. Knowledge building, there is a number of platform systems which are developed to analyze agriculture-related data. I am sure that today we will hear about some. I put here some schema from few platforms which I know you use, that Demeter, Afar Cloud, Siuser. So there are platforms which are designed. You can find that there is a number of similarities. Many from this platform was paid from European project. I can also mention Fiverr and other platform. Niva is now mainly for paid agency. What is again a big problem, and I think that it is related with some facts which I mentioned at the beginning, is to guarantee sustainability of this platform after end of the project and sustainable business. Most of this platform is trying to be focusing on farmers, and as I already mentioned, this some possibility or willingness of the farmers paid is limited, and with huge number of this application, huge number of these apps, probably will be not easy to sustain for a long time. It is not only our observation, a very similar observation came also from Copernicus market study, which was, I think, provided by Deloitte and Touche. So there is the question how will look the platforms in the future. Many of big players is dreaming that all these information systems they will put together and manage all these platforms together. There is some other things where I believe that it is the right way, and it is the system of some local broker where they will be organization who will be able integrated data from different systems and supply this for region, for local organization, but could be also for food producer and other. So these are two potential scenarios which could happen in the future. So again, some conclusion. On one side, there is a huge investment, but on other side, there is not the optimal usage of this investment. The farming sector is fragmented. It is also the problem. The education of the farmers is not all time on the equal level. What is able to adopt one farmer, many of us is not able to return. But what is also the problem that many developers is not thinking about return of investment for the farmers, because this is the key that if the farmers will invest into new technology, that his profit need to be bigger than will be his investment. And now we are coming to the wisdom, what probably is some idea, and where I see as important also the role of Open Geospatial Consortium, GEA, and other organization is to start discussion about digital twins. And from my point of view, digital twins will be mainly about interoperability, because as I mentioned, I am personally preferring some distributed model where it will be possible to share the data capacity among many players, and in the end will be supplied to the farmers. But this is not possible to done without interoperability. In Europe is now discuss a new future initiative, Green Data for All, and destination seems that there is some idea that it could be in the future combination of INSPIRE and other initiatives, and it has to support Green Deal in the Europe. And as in other areas, digital twins will create virtual replica of physical world. So again, if we would like to collect many data, we need to be able to be interoperable. So seems that this topic is important both in Europe but also on the global level, on United Nations. There are very ambitious plan, and there is important that farmers are considered for the future, not only as food producer, but also they need to produce water, air, and other things. What are the things in public interest? And the question is how this public interest will be financed, because probably if we will ask that all this has to be financed only by farmers, they will be not able to do this. What is important that in many cases the same type of services with observation data could be used for different groups, and this is something what we have to consider in the future. And this is way how we can look on the future that different players, food produce, financing sector, but public sector need to cooperate on some effective exchange and analysis of information. And there are 10 points on the end which are the part of our white paper. Make some workshop and conferences, connected people. Now we are working on strategic research agenda. We need to connect it all players. We need to support farmers with many open data on country or European level. What is important to support also research and in Earth observation, in agriculture, agronomy, it is necessary that people will work together, because Earth observation experts are not able to bring some agriculture knowledge very often, and again, agronomists are not expert in Earth observation. We need to develop new methods, of course, artificial intelligence and other. Will be good to finance more smaller independent projects, because, for example, now it's very popular in Europe cascading funding, but this is limiting to bringing new solution, because if you have to use already some predefined tools, probably new ideas will not come, so there will be good to finance bigger number of small projects. Standardization, we need to coordinate better different projects and to transfer the result from different projects. And of course, there will be a number of problems on the side of legislation and financing. So this is all from my introduction. I don't know if anybody would like to ask now. I think that we will discuss these things more on the end, but if there is some short question now, I am able to answer. No question? So, Karel and Michal, how you agree? Who is now first?
No, it's Peter's turn.
Peter.
So
Peter. Okay, so
I guess that would be me, yes.
Please change Peter to presenter.
If you, yes, please make me presenter.
Sorry, Peter, I just wanted to let you know that the agenda was put into the chat. You can check the agenda in the chat.
Okay, great. So I can start sharing myself now, and that means you should soon be seeing something.
And I would like to remind everyone to log the attendance in the link which is added into the chat. Thanks.
Okay, I still see the lineup of attendance. Do the others see my screen?
Yes, we can see your screen.
Yes, we see.
Yes.
Okay, perfect. Just wanted to have that feedback so that I don't start talking without any visual support. Okay, so thank you very much for having me here. Without further ado, indeed, as Karel has anticipated, it's getting more technical. Specifically, what else would you expect from me about data cubes for optimizing agriculture? On that occasion, by the way, the list of services that has been presented by Karel, I guess there are some updates that I will want to present here. So let's look at what the story is for data cubes. I want to briefly talk about an example of multi-factor crop health analysis, how that can go from field level to continent level, specifically using data cubes, which offer particular advantages for time series analysis, and federating such services. So the broker that Karel mentioned actually is past that we don't need any longer. And of course, the big challenge today, adding AI. Good. So let's start what we can do here. I want to present a project that has been carried out with German support. The name was Big Picture. I apologize for that. I didn't invent it. The topic was about rule-based field health classification, so per crop type to find out in-field anomalies to determine frost and drought. Rule-based means that a lot of rules have been defined that characterize this, and these rules have been combined. Actually, also combining lots of data, many of them time series like Sentinel-2A optical data, Corinne land cover, soil data, climate water balance, and all of that was done in WCPS queries. That actually made them easy to rewrite to experiment. The queries are intellectual property of the lead, Spatial Business Integration, the German SME, but it went approximately like that. If NDVI in March is still less than it was in December, and if the deviation or the difference between March and April is really small, and it was a really cold winter, then actually we might have a problem. Of course, we need to do much more here. This just shows the principle of such rules that can fire and that can be combined. Using Rasterman, that all was done in real time throughout Germany, and actually the whole of Germany could be evaluated like this in 1 hour. So that's a service that allows to get such insights and to present them to farmers specifically for their piece of land. By the way, there was another interest, not from field, but national level, because the German Ministry of Agriculture is interested in using that so that they can anticipate financial support for the farmers, so they can know how much money should be reserved in advance. Okay, scaling up here is another one. That's a European funded project called Land Support. The goal here is an integrated modeling specifically for rural development, giving policy making support on the topics of land resources, agriculture, and forestry. We do a big data repository, as people like to call it today, and offer analytics on top of that. Top right, you see a screenshot of the analytics windows that you can utilize for selecting data and doing analytics with so-called decision support building blocks. At the bottom, you see the data sets that we have collected and provide. You see that this is still ongoing. While most is green, meantime, fortunately, we still have a few blocks missing that appear in red or that are just about to getting offered, like in orange. So this is under the lead of University of Napoli in Italy. They are leading that multinational effort here. Okay, if you look into what they offer, it's tuned towards rural and land forestry and etc. So you find layers and you find algorithms on these layers for soilic organic carbon, imperviousness, for landslides, lithology, and soil erosion. So now the data cube aspects, you haven't seen much of that, although they were underneath. Actually, the problem is, well, we often have too much sensor-oriented data. Everybody says that today, but still you see most of the services offering scenes, and the products are still scenes or files, whereas actually state-of-the-art is to combine them so that we can seamlessly walk through space and time. And that makes it easier not only for humans, but also for tools. So the algorithms can concentrate on what they really want to do, for example, machine learning. That, of course, requires effort. So the current archives are not necessarily optimally suited for that, but there needs to be some homogenization step before they are ready for, well, analysis, but also ready for visualization and ready for fusion. We particularly have cases where not a human user is sitting in front of it, but queries, its WCPS queries, are generated automatically from machines. So we have machine-to-machine communication, meaning that we really have to take care of the semantics so that we can leave those CPUs alone. I've mentioned this for Letterword a couple of times. Some of you will know it. Web Coverage Processing Service is part of the Web Coverage Service suite. It's specifically a DataCube analytics language that knows about the semantics of space-time and therefore also knows about the semantic of regular and irregular grids. Here's an example to give you a flavor of it. Just on the fly, let us note that with a slightly different syntax, but the same evaluation model, there is also an ISO standard extending SQL, the database language, with data cubes. Okay, that has been done actually by the Rasterman system. So the Rasterman query language is now part of the ISO SQL standard with the actionable data cubes that have been invented or established, not just having the data structure that has been done in climate modeling since Fortran times, but having services on it. And so we have an analytics engine that allows to host and manage and serve these data with ad hoc analytics. And that is what's used, what's behind that. And let me just mention in passing, some people say Python is the appropriate API. Think back in the early days of SQL. That was in the 1970s. If somebody had said, let us not standardize SQL, but let us standardize COBOL, because COBOL is the programming language, would you be happy today? So I believe we will not be happy in future if we now base everything on a particular language, like, for example, Python. So you can do, but you don't have to do that. But now let's go the next step. So we have the data centers, and I said we can forget about the broker, and this is what has been established in, again, a nationally funded project called Big Data Cube, where we actually have established a public-private data cube partnership. The public part is Code.de, so the German Sentinel Hub. At that time, we had about 400 terabyte online. Meantime, it's much more. And bespoke products such as WindSpeed and SeaState, which is useful, for example, for wind farm planning. And Claudio, an SME, has contributed a digital terrain model, and those could be combined ad hoc and with appropriate security, which is indispensable when you go for commercial services. What has come out of all of this is the Earth Server Federation, which today has tens of petabytes available. So among others, the complete Sentinel archives. It's consisting of about 10 data centers. We have a few coming in currently. And querying is done with full location transparency. So you send a WCPS request, and it doesn't matter where the data sit. They will be processed, and they can be combined through distributed fusion without the user even knowing it. That makes it look like one big data center. And I would contend that this is the largest data asset that Europe has to offer today. You can access that under earthserver.xyz. And then you can look at the partners and what they particularly contribute. That has found the interest further away. And so Taiwanese data cubes are built up also using the same platform. And that means they actually are our non-European member of the federation. So actually what you see here is an NDVI forecast based on time series analysis over the northwestern of Taiwan as an example. And the special interest of our Taiwanese friends is to have an agro-informatics service platform that includes, for example, drone imagery. So you see, we remain in that field, and there's quite a few things that data cubes can contribute. The last thing I want to mention is AI. There is a project called Deep Rain, again, nationally funded, where the goal is to improve rain prediction for mountainous areas. The problem is, rain prediction is quite good on flatland because not much is happening between 2 pixels that are modeled. But in the hills and mountains, a lot of things, a lot of landscape is happening. And therefore, forecasts are way too coarse and inexact. The approach is to fill that gap via machine learning. And as we need big data, an array database system is used, again, Rasterman, in combination. Actually, this is quite natural. Machine learning underneath uses linear algebra. Array databases uses linear algebra. So it's all about linear algebra or tensor algebra. So a couple of data are getting combined there. This is under the lead of the Jülich Research Center in Germany. And that is the last one I wanted to present about the standards. We have the data standards coverage implementation schema in OGC, which is identical to ISO 19123-2. We have WCS, WCPS in OGC. Inspire, the European framework, actually has adopted WCS and WCPS as its basis. Here are some links with examples, demos, and background information. And as I mentioned, independently from geodata, data cubes have been added to the SQL language under the name of MDA, multi-dimensional arrays. Okay, and that's it. So without repeating what you have heard already here, let me stop here and thank you for your attention. Handing back to Karel.
Thanks, Peter, for your excellent presentation. I know you are every time excellent presenter. I'm very happy to have you every time, because every time I'm able to learn something more. Is there some question to Peter? If not, I will have one question. What is the business model for DataCube? How the services are sold, or what is the strategy for the business?
So the Rasterman model is a dual license model. You have an open source edition, which is fully functional and actually is the reference implementation for the standards. And that is being utilized in many places. So we face lots of download there. And you find, for example, non-Earth planet server about Mars, Moon, and Vesta. And then there is a proprietary engine where we sell the software, and that allows to finance the programmers doing that. And that is installed on these sites. So, for example, in the course of projects, we have installed that at Creodias and Mundi and others. And so it's running there. And actually, thanks to the financing of the European Commission, the service is available for free. It depends. So some people don't want to make their data publicly available at all. Others want to offer them at a cost. Again, others for free. So that is totally up to those service operators.
And how is in such case organize a business? Yes, because if I would like to connect it some open data, some data which are for some payment, how it is organized? Because this is something what is not trivial in such distributed environment.
Yes. So, okay, a little bit of technical background here. The technique that we use for doing distributed processing is query splitting. That is, an incoming request is analyzed and then split distributed to the different service instances. Now, every service instance will execute its own part, will process that, and then deliver the result back for integration to the original server where the request was received first. On each server, you have the information and you can do billing. So for example, in this Big Data Cube project, there is on the one hand code.de. You can send requests and you will not pay anything. And for Claudio, outside the project, that would be paid. So by the end of the month, they would confront you with a bill. How that is organized is total. This is an accounting issue. Do you have a monthly subscription rate? Do you pay per use? That is totally up to the operator. So we just provide the information to the operator what they have contributed.
So it means that every operator is billing separately, yes?
Yes, every operator is billing separately. That means public services don't bill at all, and private commercial services bill specifically. What we plan to do is that you can get the query analyzed. We do that internally anyway, but we can technically make that information available to the user so that they know what it will cost before they send the query. This is work in progress, however.
Okay. Peter, thank you very much for your presentation and answer. And Marie-Francois, I would like now ask you to move presentation to other Karel,
So I need
Jedlička.
to stop sharing. Okay.
So,
Karel, I think that you are now switching.
hello, everybody. Trying to start sharing my screen, and in a minute I should be able to do so. So, can you see my screen now or not yet?
Yes, we see your screen
with the presentation. Excellent. Okay, so good afternoon, everybody. I would like to present you some example of how the agroclimatic factors can be calculated from climatic data. But first of all, I would like to fit actually the agroclimatic factors topic into the digital twin of some agriculture topic of a farm or whatever. So if we imagine a digital twin as something which copy the structure of the physical world together with processes happening in the world. So in this case, we can understand agroclimatic factors as actually factors from the outer environment which influence the crop growth, the growth of the plant. So it could be understood as a part of a digital twin. I'm talking about factors like how much solar radiation, for example, the plant gets from sun. What is the water balance in the place where you plan to grow such a plant? About the temperatures, air temperatures, and also, for example, for the nitrogen application window, the soil temperatures are important. So if we are able to get this information about a place in advance, for example, from historical data, we can say, okay, we gather the information from some twin of the physical place. So when we started the research, we found some related works. Here is just very short findings we saw in the literature. So usually the data of local weather stations are used for such calculations. Very often the calculations are just briefly indicated, and it's hard to repeat the calculations. So we did some theoretical research to actually put all the information at one place. And for now, if you look at this shortcut here, it goes to GitHub, where there are all our algorithms available, and they are available together with the description of each particular agroclimatic factor. So you can effectively use it if you want. As we can see, there are many of them. I will describe in detail just the frost-free period agroclimatic factor. So basically, each factor has some kind of scheme, as you can see on the right side of my slide. So in this case, I will talk about the data later. But imagine we have the data like 40 years row of data. We go day by day and analyze if there is a temperature below zero, if there is a temperature below zero for at least an hour. We count that as a frost day. So this is as easy as this is. But you can do it more complex. Okay, we can search for the last and first frost day in a year. If we do several years analysis, we can search for like average number of frost days for each year. We can calculate, let's say, a probability in which you can expect a freezing day after the officially calculated last freezing day, for example. I will show the results in a while. Of course, then we can use the statistical approach to calculate also the frost-free period. We can search for trends in the data when we have the time series. and the agroclimatics factors we created, the algorithms, they are applicable almost everywhere. So we can identify based on the position which days we should start. For example, there are different approaches for southern and northern hemisphere in this particular factor. Anyway, if you take the algorithm and try to calculate something, I would like now to show you what you can calculate about a place. This is a particular place with some location you can see, and we can calculate the already described frost-free period. So you can see last spring freeze, first fall freeze. Then you can of course calculate the frost-free period, and as you can see, we use the data from 1980 to current year, so you can also analyze some trends in the data. You don't have to do this for a particular place. You can create maps like this. So I will show that maps just for the first factor. This is the Pilsen region, so you can see there is a 10% probability that there will be a freezing day in between these and this day here. This is how you can interpret this particular map. There is the same map, just 50% probability, so you can see the frosty period is a bit longer. But this is not the only thing you can calculate. The other factor is related again to temperatures, and you go for C3 crops, which is a group of crops, like for example wheat is in that group of crops, and you can analyze temperatures which are above certain threshold, like in the optimal, let's say between 15 to 20 degrees, and you can calculate it in hours or in days, for example. And you also can calculate if there is a heat stress. In this case, you can see that the very few years there were some heat stresses for the plants in the particular place. But what you can do, and what is very important you can take several years and look how the temperatures looks like during the year. So I will play with these types of graphs later on. I would just like to mention you can calculate soil temperatures above 10 degrees, which is related to nitrogen application, for example. We can discuss accumulated solar radiation, which has the direct relation to the biomass you can expect to grow. Again, you can take a look how it looks like during the year. You can see the accumulative graph as well. You can talk about the water balance, for example. So it means to know about the precipitation, evapotranspiration, and runoff, and then you can calculate again also the situation during the year, how it looks on the graph. So why do we actually? Yeah, we can see the trend in these years as well. But why do we actually calculate these? It's for something I call it the story of a plant. We have a plant or crop, and we know in which periods of year of growth cycle the plant needs water, nitrogen, or temperature, whatever. And we can take the information about the particular places, like solar radiation here, precipitation, growing degree units, and we can search like which plant is suitable for a particular place, or we can do it the other way around, so looking for places for a particular plant. This is something which we can combine with the actual climate analysis of climatic trends and search if there are some shifts, like in the specific field, if it makes sense still to work with the same plant, or maybe the characteristic of the place just change it, and you maybe should consider change the crops you are growing there. Now we should talk about actually the data. We analyzed what is the source of our data. In the current version of the algorithms, it's the ERA5 land data set, which go from 1981 to present, hour by hour, different information, different variables you can consider. But the question is about the precision. So first of all, we discussed the precision which they described the data itself. So you can take a look into something which is called EDA dataset, describing at a particular place the precision. So you can see, like they say, the data producer says that they are pretty sure about the standard deviation of the data and the minimum maximum differences. But if you consider, yes, thanks. If you consider the data and compare them with some in situ sensors, so like ground truth, you can see in this picture that they are pretty much copying the data from the sensor. Like the red one is sensor data and blue one is the ERA5 data. If you look just to the differences, the situation is not that ideal. You can see that the standard deviation is now about one degree of Celsius, which could be risky for some agroclimatic factors calculation. So we now consider to even check other data sources for this analysis. But for now, we worked with this data, and this is a future work to change the data source maybe. For now, we use a technology developed in EUSDAT project, as Karel already mentioned. First of all, again, the algorithms are available at GitHub, as I mentioned. And here is the infrastructure developed during the EUSDAT project. It's available under login, and I think if someone is willing to test it, it's not a problem. So you just need to ask for credentials. And there is a prototyping environment of Jupyter notebooks connected to various data connectors. There is a possibility to connect the script you developed in the prototyping environment into actually Elastic Cloud. So the infrastructure supports high performance computing if needed, which is something we used for some of the factors calculation, in fact. Yeah, and this is we start with the EUSDAT project. It's about to end now, and in the Stargate project, we would like to continue in the research, playing with different data sources, as I mentioned. So thank you for listening to my story of farmer examining suitability of a place for a plant using the relevant data and up-to-date technology. So that's all from my side, and I think I still have 2 minutes, Karel.
Okay, thanks, Karel, for a nice presentation. There is time for 1 or 2 questions. So if anybody would like to ask, please. Nobody, then it is again obligation for me to make some questions. So one question, do you plan also to use artificial intelligence for some type of analysis?
Well, this is something we know about and we consider that, but there are no particular plans at that moment. But yeah, for future, we feel that it could be useful to work, especially with artificial intelligence, to work especially in a way of analysis of trends. So you could see that the trends we used, these are just linear trends, a very basic analysis. So this is something which we would like to elaborate more in the future.
Okay, second question. You heard before presentation of Peter. Can you imagine that these approaches will be possible in the future in some way to put together? Because if we would like to build this digital twins, then it will be necessary that the system will interoperate.
So this is like two levels. The question first is a technical level, so I think it's possible to connect. The other thing is, the data has the same nature. It's basically space-time cube as well, just the storage is different. So from that point of view, the technical integration is not a problem. The other thing is, I don't know about the analysis techniques they use, so this is something I should learn more, and we will see how it could be connected together.
Okay. Thank you very much. And we had space data, we had meteorological climatic data, and now we will move to IoT technology. Marie-Françoise, please put presentation to Michal, and he will now make his presentation about IoT technologies.
Yeah, this is done.
So, Michal, floor is yours.
Thank you, Karel. Hello. I would like to present you. It will be better like that now. Do you see my screen?
Yes, we see. Thanks.
Yes, okay.
Thank you. I would like to present you a common presentation prepared together with my colleagues Lukáš and Ondřej from University of West Bohemia. We would like to present you our solution for sensor data that are used in or that we are using in many projects. I would like to speak mainly about what is the SenseLog, what is the structure of the application, how we are covering interoperability between systems, and where we are using this SenseLog solution. Motivation for processing of sensor data is that sensors, and especially now in domain of IoT, monitoring and sensing of lot of phenomena brings a lot of challenges and lot of tasks for processing of sensor data and observations, because these sensors are bringing and connecting the models that are modeled and simulated in virtual space with the real world. So we are able to compare what we are planning or what we are simulating and what is the behavior of the real world on one place. So that's the case where we are dealing with this sensor data. So we have developed in the last 10 years a solution called SenseLog, which is web-based or modern version, the cloud-based data management application that is able to store, manage, process, and publish sensor data in various forms. It is suitable not only for static in-situ sensors, but it can receive data from sensor deployed on mobile carrier, for example, tractors or cars or any moving object. And we are able to collect data by smart devices as well. So we have a module for collecting VGI observation as well. SenseLog is providing REST API on both sides of the chain. So we are receiving data by REST services and producing or publishing data for consumers by REST API as well. On behind, we have a database with spatial extension. So we are able to make some analysis in this database as well, or we can use external modules for processing of such data. SenseLog is a modular solution for web or cloud environment, depends on the version you would like to use. It has own data model, but it was designed and developed based on observation and measurement standards. So it used common entities, but with some extensions, especially for metadata and structure of the sensor network. We have two versions of SenseLog. The mature version 1, is web-oriented. It has several modules for mobile sensors like VGI or farm telemetry. It has proprietary interfaces based on JSON encoding of data and REST services, but it has standardized interface according to SOS service version 1. And now we are working on implementation of SensorThings API for this version 1 as well. Version 2 is a new version of SenseLog that is developed for the last 2 years. It's designed as a system of microservices, so it's more or less cloud-oriented and used common Docker and Kubernetes for deployment. It again has a proprietary API based on REST services with JSON encoding of data, but we are working in last half a year on development of SensorThings API. So we have first prototype, and there is a good point to thank to Valentis Tiekos. He's presented in the list as well for his big help with testing interface of this interface. On this slide, you can see very briefly structure of SenseLog. So it's possible to see how it is divided in small services and how it is communicating with each other. In context of sensors and application, this is this diagram, where on the left side you can see producers of data. So it can be smartphone or some static sensor, or it can be, let's say, database or data storage from some external data provider. So you can connect to SenseLog by different components. It can be directly on API on SenseLog processing. It can be by some wireless technology like IoT, LoRa, or Sigfox. So you can connect to SenseLog feeder with this protocol, and this is communicating internally with SenseLog processing service. Or we are using a system of SenseLog connectors that I would like to speak in next slide. So this is connecting to different data storage and downloading or pushing data from this systems. All the data are stored in SenseLog data model, and from this data storage, it's provided by SenseLog provider or by SenseLog connector to different components by third parties or by web components from our team. Or we can directly pull or push data to external data consumers, data storage. So again, by using SenseLog connector component. How we are reaching interoperability of SenseLog? As I was speaking before, we have implemented REST API that is covering the complete functionality of SenseLog, but it's limited amount of third-party applications that are able to work with this proprietary API. So it's a little bit complicated or not covering all these use cases that we have, how to push or receive data. So we decided to design and develop a component that will connect or translate different interfaces to our proprietary API. And with this component, we would like to cover a real-time integration of data from different data providers, services, or storages. So we decided to design so-called TensorFlow connector. So this is a component that is able to transform different APIs or services to all internal API and vice versa. So we are able to download the data or publish the data to different endpoints.
Michal, 5 minutes, yeah.
Thank you, Karel. So this connector is designed as a standalone component that is managing which sensors are downloaded, which are uploaded. At this moment, we have implemented 3 interfaces. So we have interface for special instrument file climate database for IMA Azure storage, or now we are working on Alpha Cloud project API. And under development and testing is SensorThings API interface. So this is a diagram how the sensor connector is structured. So on the left side, we have interface with a description or specification how the interface should look like. Internally, it's a different system of clients and gateways, how requests are managed. And on the right side, you see different data providers that are able to receive or send data to this connector. On this slide, just briefly, it's a mapping between SensorThings API data model and Senslow data model. So as we are, our Senslow data model is based on observation and measurement standard. So it was mapping not with much complications. We have very similar attributes that we are able to adopt, and some of them has to be calculated, but in most cases we are able to map it one-to-one. To cover, let's say, physical measurements and observation, we are very in narrow cooperation with Agronow technology that was developed by Lesprox Služby, a company. It is autonomous telemetry station. It uses modern IoT networks. It has interface for most of the digital sensors that are common on the market. And this telemetry unit is not only, let's say, measuring and sending data, but is able to, let's say, standalone cover storing and some basic processing. So just for the last slide, some examples of use cases that we are using Senslow in. So some static measuring of groundwater in Czech protected area Litovorské Poboraví. Use case of telemetry, monitoring tractors of one farm in Czech, and example of collecting points of interest by smartphone and visualization in web browser. So thank you for your attention, and if you have some questions, it will be my pleasure to answer them. Thank you.
Okay, we have. Thank you, Michal, for your presentation. We have time for could be 2-3 questions. So who is first? Again, no question. It seems that it is. Okay, Michal.
Yes.
What about sensors observation services? Yes. What do you think about this, and how you compare this with new standards?
Yeah. Let's say that implementation of SOS service version 1. It was almost 10 years ago. I have to say that with this SensorThings API, it was easier to map for us between all data models and SensorThings data model, and I think it's more effective, this SensorThings standard and specification. So, and I suppose it will be more or widespread on different systems in so I suppose more impact of this standard. Anyway, we are thinking about implementing other specifications or other standards for sensor data, like NGSI protocol, or we are thinking about implementation of SOS version 2 as well. So I suppose to be able to cover most of this very popular specification for sensor data.
So in such case, SensorLog will be possible to consider as some translator also, yes?
Yes, and hopefully as a data integrator.
Yeah. Okay. Is there some other question? If not, I would like thanks to Michal and switch presentation to Luis. It is last presentation before coffee break, and then we will continue after coffee break with other 5 presentations. Thank
you. Thank you.
Yes, hello. Can you hear me? Yeah.
Yes, we hear you well and see also your presentation.
You see the screen as well. Great. Cool. Well, thank you first for this invitation. It's the first time that we are coming to this Earth observation sector, so apologies, and please help us to make it as relevant as possible. So my name is Louis. I work for for Starting Blocks, and I'm also a PhD student in Canada, so working between Europe and Canada. And what I would like to introduce you is like Starting Blocks approach, which is how to address data silos through universal interoperability based on web standards. So coming back to data silos to what we know it's hampering the capacity of new systems to communicate and to design smart and efficient systems. Data silos, they emerged by different they stem from different aspects. Some of them, in most circumstances, data silos are created by systems that are just not coordinated, but they can also stem from strategies from some players who are willing to aggregate all the data within their own platforms. To overcome these data silos, we know it well. You have some industry standards that are getting created. So OGC is a perfect example of an industry level standard willing to address these data silos and make possible collaboration and data flows among its industries. But the fact is that once you have your industrial data siloed, comes the question about how to organize intersectoral collaboration. So how here you have 3 or 4 standards that are mentioned, but in general, for each industry you have your own standards, and in the context of a data economy comes the question: how do you interconnect the different systems across the different sectors? Stepping away from Earth observation, one use case was the COVID situation for Starting Blocks. In the COVID crisis that is happening right now, it's a perfect example of how the data silos, how sectoral data silos are just hurting the economy. On the one hand, you have healthcare institutions that are fighting to help, especially elderly persons, and who manage so to coordinate with each other through common standards. And on the other hand, you had some like local initiatives using their own data and trying to coordinate in order to make citizens able to help these people. But it's just it has just been impossible for anyone to coordinate these different services. And at the end of the day, we are not just able to address a crisis such as a global pandemic that is happening to us. So like from Starting Blocks perspective, this is really the illustration of how data silos are like impinging or preventing our own services to be efficient, especially when we need it at some like very specific stage. And we could replicate this same approach to how to make Earth observation work with the agricultural sector. What happens when two different sectors use different standards because they were not thought to be connected, because when they were created, they were like the use cases were so rare, were so random that there was no need to have a common standards. So what happens when there is the outbreak of a crisis, and that like right now you need data flows, but your systems are just unable to communicate, and the APIs are too few to be able to address the specific case you need to enter in. So what we suggest as Starting Blocks is to use the World Web Consortium standards as our basis for collaboration. And here we are really aligned with what Karel was saying at the introductory speech, like working with the World Wide Web Consortium standards in order to make possible universal interoperability. So why the World Wide Web Consortium? Why choosing the web standards? Well, just as a reminder, Tim Berners-Lee that we see here has like designed the cornerstone standards that make it possible for us to navigate the web every day. Like if you have a URL that was circulating just a few minutes ago for circulating the agenda of today's discussion, you know, you have a common URL which enables you to go to any web page. You don't have to wonder, is this web page compatible with my system, or can I click on this because it's not working? You know, we have universal standards that were designed to make possible to enable individuals to navigate across any web page in the world. And if we see like in the web services are developing, are getting more and more prevalent in today's economy, and even in the Earth observation or in the spatial industry. We saw like a few minutes ago, Michal, who is launching a new web platform for facilitating the access to Earth observation services. You have other newcomers such as Yuri or Hosmi, who also are web platforms designed to facilitate the access of the overall economy to data, which is necessary for people to benefit from the new advances, technological advances. In the agricultural sector also, you have new web platforms based on these same web standards for coordinating these different actors and make citizens able to, well, make different large amount of different players being able to cooperate and to exchange data. So the web is really for us the basis for exchanging data and making possible universal collaboration. Yet, as we know, and as Michal was suggesting earlier, if you count only on HTTP or HTML or URL standards, you cannot go much further than navigating, browsing different web pages. This is why Tim Berners-Lee with the MIT Consortium is working now on semantic web standards with solid standards, and these solid standards they go deeper into the data. They propose to standardize the way, the semantics, but also the way we authenticate, how we connect to different services, the request protocols, and so forth, in order to have an integrated semantic and technological interoperability, enabling not only to consume the platforms, but also for the web platforms to be able to exchange data on a horizontal basis without wondering if they are based on such or such technology. So starting blocks, this is what we do. It's great to have solid standards, but we need, since these standards are emerging, starting blocks is making these standards like tangible, usable on an everyday life. So we are a co-op based in Paris, and what we do is we.
So Louis, 5 minutes, yes.
Yeah, I'm concluding now. Thanks. So we are we are developing open source applications based on these solid standards. So our applications, since they are based on solid standards, they have two different capabilities. The first one is the modularity. So we develop web components that correspond to use cases, for instance, a chat, a map, whatever you may need, a library of resources, PDF generator, whatever you may need as a function, you know. So this is modularity, so that people can easily build their apps depending on their use cases. This is the modularity. And the second capability is universal interoperability. Our applications are able to connect with any other application using solid standards. I guess you understood it, whether they are based on starting blocks or any other technology respecting the same web standards. Just to come back to the COVID situation, so we collaborated with this service, which is called DOME, and whose function is to break the data silos, but they took a sectoral perspective. So they broke the data silos in order to enable healthcare services to collaborate with each other, which, as I was saying, was not sufficient in the outbreak of the crisis. So working with starting blocks, we are now working on implementing an API layer based on solid standards in order for them to be able to connect with any other organization, should they be volunteers or any other organization, potentially any organization which is being affected by COVID. So what we say is that this same approach could be implemented in order for us to connect agricultural services with Earth observation services, integrating solid standards within the ecosystem of standards being developed by the OGC in order to enable universal interoperability and to overcome any costs that are associated to integrating and interconnecting different apps. And that's it on my side. Thanks.
Okay. Thank you very much. Again, we have time for 2 questions. I hope that finally will come some questions from other persons and from me. Seems that we are not so much interactive. Okay, these APIs are described with some standard tools, or how we can learn about your APIs.
So they are based on open standards. So you can find the standard specification published by the World Wide Web Consortium. It's open. And so if you want to learn about solid standards, it's produced by the the W3C that you already mentioned previously. So it's documented online, and our own APIs. If you want to go deeper into Starting Blocks APIs, is also open source technologies. We have all our documentation on our website. So it's yeah.
Okay, thank you. Is there some other question? We have now a coffee break. Marie-Françoise, we will continue after coffee break on this same address, or there is other address?
I think we have to check into the agenda. I did not pay attention to that because I do not moderate the next one. Let me check that. So my today. Agriculture.
It would likely be the same. It was the same before for multiple sessions. This is Bart.
Yes.
I think you can. Yeah.
Yeah,
hey, Louise. Oh, sorry. Go ahead.
Yes, yeah. I think it looks to be the same because I don't see any other address. So I think it's the same.
Okay, so we will meet in 30 minutes. First presenter will be Walter. I would like ask all to continue also for the next session, because we will have there half an hour, which I would like to use for discussion. Eventually, if anybody would like to present it, some other projects, some other activities, there will be time to do this. So please join us in 30 minutes, and we will continue with a full presentation and then half an hour discussion where we would like to discuss what we can do in the future, how we can cooperate, because we heard about a number of platforms, usage of a number of standards, and what is important to future come from single projects into some testing among the platforms and some broader cooperation. So thank you, Marie-Françoise, for assisting us with this part. Thank you to all speakers from this session, and we will continue in 30 minutes.
Okay, we can keep the line open here. Hey, Louis, I heard your presentation on Solid. I have forwarded the topic to George Percival, CTO of the OGC. I'm also in contact with some of the folks from Solid, Ruben Verborg from UGent, which is around the corner here. Or, yeah, I'm based out of Brussels. And see how we can pick up on this in either as a topic in OAB, which is the architecture board, and see how we could, what our relationship should be with Solid.
Great.
So yeah, thanks for that great presentation. Appreciate that.
Cool. Thank you so much.
Okay, thanks.
Bart.
Yes,
I do not see the second part of the agri session into the calendar.
Well, it is there.
I have the agri, yes, but on the portal for the GoToMeeting, I see the agriculture digital twins from 8 to 9:30, but I don't see the second part.
Then the people register for this one. That's fine.
Okay, but I will not. The GoToMeeting will not stop if I
No.
Okay.
Yep. Hey, Louis, got your private message. I'll let me ping you right away. Where are you based out of, Louis?
Excuse me?
Sorry, what?
Where are you based out of, Louis?
Currently, I'm in Prague, actually. Currently.
Oh.
Yeah.
Good.
But yeah, I will pass by Brussels, and we are in contact with UGent also. So I think it would be definitely interesting to have a discussion with you guys whenever you want. I will also pass by Brussels in the future.
Yeah. I can reach out to Ruben as well. And,
yeah, we are in contact with him. Yeah.
Yeah, I bet, and see, what it is that we need to do. So I linked it mostly, maybe wrongly, to privacy, authentication, security. After hearing your talk, I'm hesitating.
Well, it's broader than this. Yeah.
Yeah.
So am I waiting for an email from you? Will you?
I will just ping you, and then I'll leave it to my role in the OGC as I'm president of the organization. I will leave it to George Percival, who's the CTO, and react on the. I think we first need to see technically if this is something that fits in.
This conference will now be recorded.
Okay. Hello, for second part, I would like to invite people who was on the first, but also who join us now. We will start now. And as first speaker, we will have Walter Maier. Could you give to Walter presentation?
Yes, I switched on the screen. Does it work?
So, okay, Walter, floor is yours. So,
do you have the screen, Karel?
I gave it to you. You have to accept, I think, Michael.
Webcam I have here, and the screen should be there.
I see you. Till now, not your presentation.
Not my presentation. Switch on the screen.
You have to push this button between microphone and camera.
Yes. This I did. Connection transferred.
Wow.
It comes available or not?
Not yet for me.
I still have your webcam.
You have my webcam. Yeah, that's okay.
Marie, you have to make Walter Maier the presenter.
Yeah, I did.
Okay, I still see it for.
I'll send you again an invitation.
You are the moderator. Okay, now is something. You are the moderator. Is here. Then I can click here. It should work. Now it's okay.
Yes, now it's okay.
Okay, great. Now then I go through. I make it bigger and start.
The floor is yours.
Okay, thank you very much. I have to welcome everybody. Thank for the presentation. What I will talk a little bit is sustainable management of the nature, but under this perfect model that we had, focus on the whole climate change question. Okay, and supported naturally by time-related satellite image. So at the beginning, I just show you something that's of interest because you see the big difference of the nature. You see a tree, and there's a small guy. This tree has cubic meter like 5,000 hectares, and here you say a micro, a nano, a pico element. That's also nature. And when you look here on the picture on the left, you see some image from a satellite. This is data for me, and I would like to go to information. That's the other picture. So that means when we go through the whole slide, you see also where we started many years ago with GIS systems, the where, the when, and the what. We were the first one who had these main questions solved. When I want to plan something, also ecology side, I need the where, the when, the what. So now the next, this I skipped more or less. This is what we did in the last 20 years. We have our own GIS. We have the GIS as we were the first with raster and vector data. The right picture on top shows forest office. Then we have farm management. Then we have GIS. Then we started very early with logistics. That means mobile sensors and mobile, more or less, ortho images transferred. And we started also 15 years ago with the first precision farming tools. And we integrated a lot of different others. So that's what we had since 15, 20 years installed in around 40 countries. The next is what we plan in the future and what we did in the last 2 years. And that means we have a lot of information collected, and the information gets bigger, 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 like all the others. And when you come to new type of information to also manage climate change question, you need more and more information. But the nature is something rather similar. That's always a similar thing and is the same more or less. And again, what we developed in the last 2 years, and this is for me, for the climate change question, for the ecology question, the key thing. Here you see a picture. This is a forest in a mountain nearby here, 10 kilometers from here. You hear everything? Hello?
Yes,
I don't hear an answer. Everything okay? Okay, now you see on the right side. This is automatically developed from the left picture in few seconds now. We call it IDIMA, identification of images. That means I get out of data on the left top, I get information on the right top. The color I had to define once, but I see here, I see alpine meadows, I see slopes, I see houses, I see meadows, they are not healthy, I see different type of trees, large tree, birch tree, etc. So this I can do automatically. And this is done in few seconds. That means I can build up such an information management tool in every country very quickly if I have the good images. So change from data to information. Also important for the climate change question. But we can go further. This is a part of our city. The left picture is a standard ortho image. The right picture is an evaluated image that shows me spruce, the birch trees, brown houses, the gardens, and is digitized automatically on another layer. So that means we jump really a generation ahead that we can develop a cadastre or an image and get out of data information. That's the next step when it goes to precision farming. On the left side, you see a picture. On the right side, you have on this picture different colors to see. And the different colors show how many tons per hectare. You can calculate this automatically. Again, a giant step forward to know for precision farming what and where and when to do. So this is the thing what we have, and then a few questions where I go to climate change also, that you see how much we can do with images or with Sentinel image or whatever image. This shows, and this is first time I show it public, it is Corona map from March. After March, you didn't get it anymore. But it shows where is Corona on a map. It focused on US, on Europe, and Southeast Asia, Japan, Korea. Where you have maximum emissions, you have maximum Corona. Very simple. This is the same, and this shows Sentinel image. On the bottom, the two images, you see a brown color. This is north of Italy between Milano and Torino. And it shows there is a lot of NOx emission. Sentinel picture shows NOx. NOx shows where is high traffic and high industry. So it shows sometimes the relation. And when we take the next picture, these I also got, it's not yet anymore available, I got from the US. On the top picture, you see Corona cases. And on the bottom picture, you see coal and gas energy supplier. I don't mention anything. You see the result of too much industry things in the air or in the soil, also at the Corona maps. Just the same. I'm not an expert in this question, but please be aware, but I do 30 years I was involved very much in dying forests, just the same situation. Now I come back to the, how can we manage better our nature on an ecologic and economic target? You see, I did on the left, this I did myself. On the left top, I ordered an image from a satellite. You see this? Left top. And then I was drawing some small elements that I manually, with experience in this region, evaluated. And say, this is a field, this is a meadow, this is a young forest, this is an old forest, this is a sick tree or a healthy tree, this is road network, forest roads or highways or whatever. Then we defined a color model. You see on the right top picture, you see the colors. We ordered the different elements, we ordered colors to it. And then we said the system, please digitize. Oops, it was done. 5 seconds later, we had digitized the whole thing. So we can do it more or less with good images globally. That means it's a giant step forward. And how did we do this? If we have an image, this image was 0.5 meter resolution, then I have the different colors on 0.5 meter resolution. When I take a drone, then I have millimeter resolution, fine, but I don't need always millimeter resolution. I show the next picture, we show the mathematical that's between there. But automatically out of the definition of an element and the color relation, I create a map. And the next step we are working the moment on, this is still more important, we need a time management, because the key problem in the nature is always change over time. And to be aware of the change over time, you need to know or to understand two pictures. Maybe one in spring and the other one in autumn, or 5 years between, or whatever. Because the nature has a giant possibility in change over time. The humans not. Nature has time. This is one of the key problems with the corona now and with many other things we had. What we did for evaluating of the climate change question is now we created in the last 2 years, it was a giant job. We had roughly 60,000 data collected of 193 countries. So more or less with 193 countries, I can now very precise define how much forest, alpine, meadows, etc. How much is the business turnover? How much is the damage there? This I can calculate automatically. So I can the economic and the ecological target of every country globally finalize and calculate. You got this? Hello?
Yeah, you're good.
Okay, you listen, fine. Then some points at the end that we see we have a problem. So Corona made awareness. But when I say in total, there's the emission problems of today is calculated, we should evaluate the CO2 problem. It is a CO2 problem, no doubt, but you see on the right 100%, the CO2 with water gives carbon dioxide and it's sprinkling water, fine. But the SO2 gives sulfur acid. The NOx gives nitric acid. These both together, no, only sulfur acid has 80% of this. So we don't have a carbon dioxide problem alone. We have another problem as well. People don't want to talk. When I add on NOx, I have exactly the same, maybe like 80% or maybe 120. Nobody made the calculation yet. And I have 1,000 other elements. They all are linked to the nature, to the ecology, and also to the climate. So this we have to be aware what's ongoing there in reality. Because someone who is on the winning side does not want to talk about the losers. And exactly, and the nature is one of the losers. And this I managed already 30 years ago. And I had just some numbers for you to understand a little bit better because it's new for you. I won as an expert at the court 30 years ago in Austria against the two biggest energy suppliers. We closed coal energy 15 years ago already. And when Germany said they will close in 2030, they said, wonderful what Austria did, but I made 2 high court decisions. Therefore they closed because they had to pay because the forests had a problem. On the other side, from the energy side, I don't beat again any energy guy, but please, we have solar energy, water energy, wind energy, and geothermal. Solar input, this I didn't know also my side, but the solar input on the globe is 10,000 times more as we have consumption globally. Pop, it was new for me too. And we have other energy forms. And we have a lot of energy suppliers, they work with mountains, especially in the mountains with water. It's not
Walter,
always nice.
5 minutes, Walter.
Okay, fine. This will be in time. That means I have recognized permafrost in Siberia. Now we get it in the Alpine mountains. In Switzerland, a little bit more because they are between 3,000 and 4,000 meters. We are between 2,000 and 3,000, up till maximum 4,000. But it starts already. So this will come. That means that we have a lot of problems today. It's nice that we use SUVs or these cars with 2.5 tons Wonderful. Then we drive home with 2-liter milk or with 5 kilo. Yeah. So we developed a model that we have to change because it has a big pressure on the nature. The nature has time to change, the humans not. This we have to recognize. So we have a lot of things to change. And what I did, and I think we have been the last 2 years, the first one, I made it ready, the calculation of ecology damages. Because beside IT and between agriculture and beside agroforestry, I was the expert of the court for the valuation. So I have now a detailed model ready for the globe that I can calculate the damages. How much was destroyed? And this will come, and this I will put in the next 2-3 months out and say, when we change, we know that we are in front of a big change because of ecology. But I also am aware how many new jobs will come. And one big thing will be jobs with the brains, jobs with cooperation of businesses, jobs with ethics, medicine, nature awareness, balancing ecology and economy, etc. So we have a new thinking, and this is what was in the EU for Agri my main task, to discuss about this ecology question and also about the climate change question. That's it. Any question?
Okay, Walter, thanks. Who has the question?
All confused.
Well, okay. Is there any question or no? Nobody. Okay. Then Walter, you mentioned about the number of analyses. These analyses are provided online or offline, or how they are available?
They will be available. They are in the moment we do it in the office for customers, okay? But it will be available. We built up a huge, total new business model also, because I think very simple that a global problem you cannot solve from a single country. You have to cooperate because the nature is different. That means we have to have a global cooperation with some elements that's important, big data sets, but we have to have local experts. Sorry, I am as an agriculture forest expert, I have no idea which trees in Ghana grow. Or please try a Mohammedana with a camel from +55 to bring to Siberia to -55 with another animal. They cannot survive. That means we have always in nature local experience that we have to define and to cooperate with global needs. There we have it. And this we try to build up, a total new business model. A little bit complex for now to explain, but it is ready. It's a big cooperation. The background is a cooperation model.
Okay, thanks. Is there some other question to Walter? If not, Walter, thanks for your presentation. Next will be Valantis. Bart, you are managing the presenter, or Marie-Francois, please give the floor to Valantis.
This is done.
So, Valantis, the floor is yours.
Thank you, Karel. Hello, all. Can you hear me?
We hear you well, and also we see your screen, but they still now only open PowerPoint. Now it's okay.
Okay, great. Okay, so hello all. My name is Valantis Tsiakos, and I am a researcher in the Institute of Communication and Computer System located in Athens, Greece. I will give you a presentation about an integrated Earth observation based toolbox that we are implementing in order to achieve the needed modernization so as to meet the objectives of the common agricultural policy in EU, and also assess the respective environmental impact. So, okay, so this is an EU-funded project involving 8 partners from 5 different countries. where our group is being coordinating. So the main, let's say, goal of the project, as I mentioned, is to facilitate the modernization of the common agriculture policy as it is being applied in the European Union, encouraging the paying agencies to gradually substitute on-the-spot checks with the system of automated checks based on Earth observation, and particularly in Sentinel satellite systems, while also utilizing other technologies like geotagged photos or data from drones and so on, so as to provide the necessary digital evidence and verify the compliance with the farmers' declarations with the legislation in place, and also to provide tangible proof about a positive environmental impact of the green policy in the European Union. So the main objectives of the project is to demonstrate the capabilities of Copernicus DIAS cloud platform to a TRL7, enabling us to build a country scale or even continent scale Earth observation based monitoring system for automated monitoring of the green direct payments. So we want to improve the resolution of free and open Sentinel data. This is done in twofold, by increasing the resolution of the coarser bands of the Sentinel-2 data to the resolution of the finer band, meaning going from 20 meters to 10 meters, and also to combine various sources of information with high resolution drone data and other commercial data, applying data fusion to super resolution techniques that will allow us to monitor small parcels and also be able to consider information about focus areas. Additionally, the project aims to develop a system, complementary to the Earth observation data system of ground-based geotagged photos, particularly important for small parcel-dominated regions that will ensure that photos are taken with increased positional accuracy and suitable orientation, and that are tamper-proof when they are provided to the paying agencies. The implementation of a low-cost system on spectral sensors that are able to measure and assess the soil quality in a given parcel. The automation of the process of deciding on beneficiaries' compliance. So in EU, the current Common Agricultural Policy implies a series of rules, and also the same will go for the next period after 2020. So currently, this process is conducted for a small number of the parties in the jurisdiction of each paying agency in each member state. So the goal here is to automate this process, being able to combine all this information and provide a service-based tool that will monitor farmers' compliance to the Green Direct Payment Scheme conditions, and something to be directly exploited by the paying agencies, and also to design and implement an environmental performance tool, as I mentioned before, that will harness machine learning techniques, establishing an inferencing system that will be able to assess the environmental performance of the applied conditions in national or even in regional or even national scale. So here it is the DIONE concept in a nutshell. Okay, as you can see, we consider three main components. The one involves the DIONE Earth observation components that aims to provide information, the main data source of information regarding the crop type maps, identification, delineation, the monitoring of agricultural activities like mowing or grazing and so on. Also the identification of non-productive ecological focus areas that so far it's been neglected due to the limitations of the Earth observation data. And also another part it is the farmers' tools, where here we consider through low-cost portable devices like spectrometers and mobile applications like geotagged photos to be able to collect information about the compliance and also about the soil conditions. And the Green Accountability Toolbox, as we call it, that it is aiming to exploit all the information mentioned, provided from the previous tools, and automate the compliance checking, including also an assessment of the environmental performance and proper visualization for the public. So going more into more detail, the Earth observation component aims to harness the Copernicus DIAS cloud platform capabilities and be the backbone of the Dione system infrastructure. So the main functionalities here are to implement an automatic chain to retrieve and process all Sentinel constellations, and also to implement the processing cycle that will capitalize on machine learning and data fusion techniques for data synthesis and recognition of relevant landscape features on parcel and regional country level, and produce improved Earth observation-based products. So here it is also in a nutshell what we plan to produce. This may range from thematic maps from permanent pastures, crop types, farming activities like mowing, plowing, grazing, and also ecological focus areas like buffer strips along the side of the parcel, fallow land, and so on. So one of the let's say components of this toolbox, it relies on super resolution techniques. So basically, the super resolution we have already designed. We're planning to implement a deep neural network architecture. So the main goal here is to being able to use the current Sentinel-2 data and downscale the coarser bands, meaning the ones that are captured in 20 and 60 meters, the resolution of the finer band in 10 meters. So this is will be implemented through a deep learning scheme, aiming to model the relationship between the bands without the use of any external or any other, let's say, additional information. And this is being implemented in Python programming language. And also in terms of the we plan to introduce in terms of the evaluation of the contribution of the super resolution Sentinel-2 images. It is to create several classification maps of a predefined and represented area of interest where ground truth data is available, and be able to feed the machine learning scheme employed for the classification task to be employed in this model. Okay, moving forward, also another component of the Dione is an unmanned aerial vehicle platform. It is a typical, let's say, data set, a typical, let's say, platform, and it is widely used in the context of agricultural monitoring activities. So the goal is to deploy this platform in the context of problematic cases where we're missing data, and we would like also to use to complement the Earth observation data that we are capturing. So on the right side of the presentation, you can see also an overall architecture starting from the flight process. We plan to use open source tools like Mission Planner and Autopilot, so on to the post-process level, while until the extraction of the orthomosaic. And all this information is going also to feed the super resolution task, in the sense that apart from the improved resolution Sentinel-2 images, the Sentinel data are meant to be combined also with very high resolution data, aiming to establish, let's say, a super resolution system that will be able to identify also parcels at an area, let's say, less than 100 square meters. Also, in the context of the farmers' tools, as I mentioned, we plan to implement a farmers' geotagged photos framework. So the main characteristic of this application is to ensure a high degree of quality and trust. So in this context, different techniques are going to be employed, like the dilution of precision, which specifies the additional applicable effect navigation, satellite geometry, or positional measurement precision, along with additional information such as the elevation that will be used. And also, we're going to harness the EGNOS services and the dual frequency supporting the mobile devices in order to ensure also improved positional accuracy. And of course, one of the other aspects that it is important in such applications is to ensure the data validity and the integrity of the application. This is achieved through the application of image forensics techniques that aim to ensure that the image is not manipulated at any stage, since the data acquisition and until the deployment of the image to the paying agencies infrastructure. And also, another important aspect to highlight, and the novelty of the system, it is the use of AR, of augmented reality features that aim to support the data acquisition process. This is basically, and also minimizes the error in data collection. So imagine that the user will be able to, from a viewpoint, and within a few seconds, to be able to see the limits of his parcel, and simply that will be superimposed on the image, and other identifiable landmarks, and in this way be able to adjust the way that the photos should be properly captured in order to facilitate the verification of the compliance status of a farmer's parcel. And also in the right, I have included a preliminary application wireframe that it shows the homepage and how the overall application will be structured in a simple and easy to use format, while harnessing capabilities from, as I mentioned before, from other systems like organization systems and so on. Additionally, we should also mention the low-cost sensors in order to evaluate the land degradation. So we have some miniaturized spectrometers capturing information in the visual and near-infrared electromagnetic part of the spectrum. Okay, so the approach here is to use this information and translate this to key soil properties and indicators of soil health. Okay, so this would be achieved in different tiers. So we have let's say, following the reception of the measurement securely in the database, the data will be cleaned, assessed for validity, and transformed from the spectra to key soil properties using machine learning models. And also after this, we're going to assess the assessed soil properties will be fused with other data streams, such as set observation data from Sentinel, in order to derive spatially explicit maps of key indicators, which will allow us to monitor and evaluate the land degradation over large areas. And also you can see the approach in the overall approach in a schematic way in the figures. And so in the end, what we have is a accountability toolbox that, as I mentioned, aims to assess farmers' compliance. So the goal here it is to be able to exploit all the spatial related datasets that are going to be produced in the project. Standard scope type maps and other thematic information, and be able to produce added value information in an automatic way and derive automated decisions on the farmer's compliance through a rule-based engine that is going to be provide insights to the inspectors and the paying agencies about the current status of each parcel, and subsequently be able to communicate the information to the farmers. For instance, in cases that, let's say, the evaluation of the compliance through earth observation data is not possible, through the system and through a dedicated API, the users, the farmers, the users of the Geotagged Photos application will be notified and will be requested to collect additional information about the parcel in order to facilitate the assessment of the farmer's compliance. And on top of this, we have the environmental performance tool. This will be based on artificial intelligence and related algorithms. So basically here what we would like to do is to insert, let's say, the perspective of assessing the environmental performance of the common agricultural policy conditions. So this is done preliminary by implementing a KPI-based environmental assessment of the greening, and based on this, to synthesize these key performance indicators in a dynamic way using the data from different sources, and the output from this will be provided also through a user-friendly dashboard. So in terms of the first part, and currently the first part of the analysis is already conducted. I mentioned the definition of the key performance indicators. So the whole process starts with the agreed upon environmental priorities that are essential for developing the knowledge and the monitoring of progress towards the environmental goals that are delineated by the Common Agricultural Policy. So in Dione, we follow an approach by introducing the concept of essential variables as an intermediate value between the environmental Common Agricultural Policy goals and then appropriate observations, data sources. So in Dione, Dione proposes the implementation of the observations towards essential variables, indicators, and policy goals workflow are depicted in the figure. And once established, this procedure will be ready to be replicated for relevant entities or stakeholders by lifting the barriers from data to knowledge, contributing to a speeded up implementation of the environmental performance assessment of the Common Agricultural Policy. Also here we can see the already identified indicators. So moving from a simple structure to a list indicated the main environmental priorities around land and soil, water, air quality and climate changes, and other protected vulnerable areas, and what are the means of measuring them. And also the selected indicators can be used to show progress towards fulfilling the EU standards on good agricultural and environmental condition of land. And here it is in a nutshell the overall Dione architecture that as I mentioned before. So as you can see in a more, let's say, schematic way, how the different components are being connected with each other and what are, let's say, the main functionalities offered by the tool. So the presentation layer involves all these dashboard and web applications that facilitate access to the users to the related information. We have the business, the service layer, that is the Dione Toolbox API, being the heart of the system and allowing the fetching and designing of information from different Dione components to a central spatial data infrastructure that will be also be responsible for making the data available to GEOS, but also interoperability in an interoperable way, adopting OpenGL special standards. And on top of the service layer, there is the business logic, that it is all the artificial intelligence and analysis of the information collected in different phases of the component, aiming to provide valuable insights about the compliance status of a parcel at a given time. So this was in a nutshell. Thank you very much, and I'm at your disposal if you have any more questions.
Thank you. Valentis, are there any questions? If not, I will ask in the relation with my first presentation. Is there some possibility for farmers to use this data not only for reporting but also for could be someday analysis to manage their production?
Yeah, basically the main use cases that we are evaluating in the project are around the compliance monitoring. So there are ways that these resources will be accessible through the platform, and of course they can be used. In the use cases that we are examining, the main beneficiaries are the paying agencies that would like to assess the compliance. But of course this information will be also made available. I mean, information about the crop type maps or information about the environmental status of the plots. So this information could be used by any type of user, but mainly in the use cases that we're evaluating, farmers are in the position to check and have an easy way to verify their compliance according to the existing regulations in each member state. To check if they follow appropriately the relevant regulations in place, and if they are in position, let's say, to easily even not to validate themselves and be able to receive the green direct payments. But in principle, anyone will be able to access information and use it as they see fit.
Okay, one more question. In the topics, you are similar to other project focus on payment agencies. NIVA, is there some cooperation or coordination with NIVA project?
Sorry, I was muted. I'm aware of NIVA and also some of our end users, one of the paying agencies being involved in NIVA. It is also in Lithuania. It is also part of our project. But at this stage, let's say, of development, we're aware of their process and what they are planning to do in terms of the AX system. But at the time being, we don't have any synergies as our, let's say, system is currently under development.
Okay. Any other question? If not, I would like to thank one more time to Valentis, and I would like now wish to Zara good morning. I think that you have now early morning. Yes, Zara, are you there?
Yes, can you hear me?
Yes. Now I have to check. Is the time for Zara or Stefano? Who is first? Sorry. Oh, Zara. Okay, yes, it's right. So, Zara, you have problem to make a presentation from your computer?
I will let your team do the presenting if that's okay with you.
Yeah, okay.
Oh, I give you the screen then, Karen.
Okay, good, fine. Do you see the screen?
I see, yes, thank you.
Okay, so tell me when I have to move with for other, yes?
Great. My name is Zara Khan. I'm working in the business development team at Planet, and I've put together a few quick slides here. I'll keep it pretty brief and succinct. We've done a lot of work with agencies in Europe to date on the CAP program and also working direct with JRC, but I just wanted to give a snapshot for the team on the line today. So if we move to the next slide. It's a PDF, so you might have to scroll. There you go. So just a quick snapshot. Many of you have come across Planet in the past. We are an Earth imaging company, so we create Earth observation satellite data. And here are our Dove satellites. Exactly, you can go to the next slide. You'll see here are the Dove satellites. As you all know, where we pushed innovation in the aerospace industry was to develop an integrated company that can both develop the hardware, work on the software delivery, cloud-based platform, and on top of that, build the solutions that the end users need. Could you go to the next slide? So one thing I wanted to highlight is that we actually have a pretty robust European team. About a quarter of our team is based in Berlin and throughout the rest of Europe. We have our mission control and engineering team. Really, a lot of our tasking operations are based out of Berlin, and almost half of our Dove satellites are sourced from European companies. So one thing that's exciting is having a local presence really helps us understand the unique needs and requirements of all types of users, including the government agencies that we're referring to today. Next. One thing that's also important to highlight is we have exposure and experience across a variety of sectors. And so one thing in agriculture that's been brought up in some of the presentations is working direct with farmers. And we do have experience working through channel programs, particularly with private sector. You can think about European companies like Bayer, Syngenta, BASF that are using Planet imagery today through their other types of solutions. And so we have seen our data operate at scale to provide field level insights throughout global companies. But today we'll be focusing specifically, as we discussed, with the programs at hand. Next. I've just put a few examples here of use cases in agriculture. For those of you on the call, we have quite a technical audience. This spans across a lot of Earth observation satellites. So yield prediction, crop health, crop classification are just a few, but the universe goes on of what you can do with the data as soon as you start mixing it too, which we'll get into with data fusion. But next, please. I wanted to highlight here an example of where we've done a pilot with JRC. What is critical is that we show that we're getting pretty amazing traction. What you see on the workflow, the diagram with the yellow boxes, is that we were contracted to work on 16,200 agricultural fields for the 2019 growing season in Europe. What we were able to do was develop a time stack table per field, providing the spectral band values for 8 representative points, plus the cloud, shadow, and haze conditions. For these, about every half week between March and October, and these were inputs for machine learning algorithms. Those were developed in the format of a file. Another output, which is the other end of that kind of two-pronged diagram, is the stack of related and aligned 4-band raster image that were used for spectral value extraction. And we were able to clip those raster images down to the field boundaries, which is critical given the unique field sizes and the shapes and everything in these areas. We were able to clip down and really optimize the download of those images. And what's exciting here for Planet is, why are these images being used? This has been discussed in the program so far. think of something like grassland mowing, where you would have a sharp but shallow drop of NDVI values. And these averages of the agricultural parcels would be over the managed grassland. And that drop would be followed by a fast recovery, which can be followed by other drops of the same nature throughout the growing year. As the grassland is mowed, you'd see that same pattern. And another example could be, for example, plowing of winter cereals. Here, the NDVI value alone can play, a marker. It can serve as a marker in this scenario. Plowing can be detected by a very steep drop of NDVI values, unlike grassland that's a little bit more shallow. And they'll stay low for a while and then gradually start to increase versus grassland, which will have more kind of ups and downs. But these are the types of examples that we worked on together. And you can see here at the bottom, we're showing what the NDVI value would be with a marker event. So that's some context for what kinds of marker events that we were measuring. Next. So I wanted to go one level higher and talk about what drives value for Planet customers. Next. I've included 5 key capabilities that we know are currently providing value to partners like JRC and others that we are working with. I'll start with daily monitoring, and then we'll get all the way into how you access the data. So I'll go one by one through each one of these and show an example. Next. So here is an example of, what do we mean by daily or near daily, you can say. This is for a particularly sunny region. So we're lucky here in California where I am that you unless you have the wildfires right now, you usually have sunny skies. But what we're seeing here is that we're near daily. There will be a few days where we don't get coverage or partial coverage, either due to, flyovers or clouds. But in general, you get a pretty good capture. And we're making new advancements that I'll cover at the end of the presentation about how you can actually get daily using data fusion and gap filling methodologies. Next. I've also shown here how we're aligning our spectral bands in order to be compatible with Sentinel. This is critical given that a lot of our users are using multiple data sources, and the more we can make our data interoperable, the more value we can drive for the end users. So here is the spectral resolution of our new line of satellites. Some refer to them as the Super Dove. So this Dove next generation satellite is going to be what we can use to make sure the data can be harmonized and switch between different sensors. And really the vision here is sensor agnostic analytics. Next. Another theme I touched upon was global coverage. What is critical here is that as a paying agency or as a member of one of these programs, you're able to know that you get your entire country covered with the PlanetScope data. This is critical if you want to do wall-to-wall or monitoring by satellite programs. This is really where you want that level of consistency, and you want it throughout the growing season for every field, and that's what we're really able to deliver. I've put some details here about archive. That's something that might be critical for certain use cases where you want to understand last year's performance or the year before. But in general, in-season monitoring is where we're seeing a lot of traction. Next. Another topic that's critical for Planet is our 3 to 5 meter imagery is able to offer the field level resolution, and not for any field, but in particular for this very narrow, uniquely shaped fields that where we're able to really support and complement Sentinel imagery. On the left, I'm showing where JRC has demonstrated that, parcels are less than half a hectare. These would be the ones that are blue. And so you see a few here in Italy, Portugal, Spain, and other regions that there's pockets of blue where you would need a higher resolution data source. And our vision here at Planet is how do we support to fill in those gaps and to make it as seamless and as easy as possible to leverage our data to support the decision-making of the different paying agencies. Next. I've talked about efficient access. I think what's critical when you're moving such large amounts of data is the ability to access that data as it comes in. And the secret to our success has been building everything in a cloud platform that's accessible, scalable, and can be used anywhere by any user who wants to either use an API or even our GUIs or web-based tools. So this is what we offer today. As you can see, we're ingesting lots of different types of data into our platform, and what's exciting is allowing our users to define themselves how they want to consume it. Next. So I hinted at what's coming, and what I'd like to go into is a few quick topics. This isn't everything we're looking into, but this is a topic that's particularly relevant for this audience. Next. So the theme has come up many times in this talk about data fusion. Here in this image, it's actually a time series that you'll see in the presentation slides when we share them, but it's a capture here of the left, which is the RGB, and the right, which is NDVI. And it's a time series that would actually flicker through the video. It's not playing right now, but we can share that afterwards. In essence, what we're doing here is we're able to use data fusion in order to integrate different underlying data sources and get you gap-filled near daily imagery in order to run your analyses, in order to capture the specific date where an event is and isn't taking place. That's the kind of support we want to offer. And these harmonized stacks, what we're hearing is that it's able to support the decision making. And what validates that is you've heard the same theme throughout the presentations today, is that more than one sensor is really where the value's at. And we're building our entire platform in order to allow not only our data to be consumed, but leveraging other data sources. So on the next slide here, where you see the different days, we're just showing where you're able to see our data fused with other data sources and get an actual near daily capture of the different fields. So this is from that previous NDVI image. You're able to see the evolution over time. Each one of these is a specific day for that field. And you're able to see how the different values have evolved over the course of a few days. Next. And the key takeaway here is that we're harmonizing the data set with the other sources that are in use today. So this is depicted here by the blue line. So you're able to see that we're getting closer and closer as we move forward. And our goal here is to eventually align with that and have our data available so that users can have a really clear snapshot and make sure our data today is delivered in a format where you have a harmonized version, that you are sensor agnostic and receiving just the outcomes you need and the solutions and the insights, rather than having to do the post-processing yourself. Next. Thank you.
Okay, thank you, Zara. Are there any questions? Again, no question.
I have a question. What is the cost of planet images?
It's a great question. I think what's important for us is that we offer a different type of solution for the specific market. Our commercial imagery pricing needs to be thought of differently because oftentimes the pricing for this use case would be on a parcel basis versus looking at something like square kilometers, which is a much larger area. So I would encourage that I connect you with our sales team who does those conversations directly. And so sales@planet.com would be the best way. But to give you confidence is we're actually rethinking our entire commercial model to support this so that we're offering you on a per parcel basis and engaging directly that it's a way of doing business that's not charging you for data you don't need, including operations like clipping and other things so that you're not getting excess data. I don't have a clear answer for you, but I want to confirm we're working on that, and I encourage you to speak directly with our sales team.
Any other question? Okay, so I will ask also the question which is related with this, because a lot of things with new satellite data is the research. Do you have some program for supporting research activity?
Yes, we've actually been engaging directly with JRC and others on pilots, early research. For academics, is there a question for research related to, universities and academics?
It is related for any type of research. Could be academic, could be some research in Horizon 2020, where also private sector participate on research. What are the general conditions?
Absolutely. We have engaged on Horizon 2020 as well. Obviously, it's a very large program, so we're one piece of it there. And so we want to proactively participate jointly with organizations that want to partner and leverage Planet data. Again, reach out to sales@planet.com and our Berlin team will get in touch with you directly to make sure we incorporate you on proposals or you bring us and our data in. And our goal is that, if people have custom solutions, they can build on Planet. We want to just be the data source behind you. If you want to do joint partnerships, we can go above and beyond. One thing on academic use that's very important is we have a program called our Education and Research Program that allows for researchers with an research only license to start testing our data. And that's really critical that you can do it through universities. And we want to enable the next generation of researchers and scientists to start unlocking new use cases. And that is offered either highly discounted through universities or for certain education users with your university email. You can get a small sum of that every month. You can just get a small bucket of data. Another avenue is to use ESA EarthNet. We are one of the third-party missions, and we highly encourage to apply through ESA EarthNet in order to access data for research purposes. We've specifically partnered in order to allow this program to give out data to people who have gone through an application process. And for us, what's exciting is the types of use cases that come out of there. When we develop products ourselves or we work with a handful of partners, you get a handful of solutions. But when we engage the scientific community, it really unlocks the value for Planet, for our users, for the entire community. So if you have any questions, we have, like I said, an entire team in Berlin working closely with JRC, ESA, and others to make this data readily available for researchers.
Okay, I have one more question. You mentioned the data fusion with Sentinel or Landsat. Can you explain me a little more? It is the resolution of this Sentinel is in some way recalculated on the resolution of Planet, or how is done this data fusion?
Exactly. Think of it as bringing the Planet daily frequency and the spatial resolution coupled with the high, gold standard quality of an HLS product. And what was missing from the presentation was the time series visual, because I sent a PDF file so you couldn't see that video. But what I do encourage is, if anybody's interested, I can get you directly in touch with our technical team that's really investing in this new product. For us, what's critical is that we work with you all to see where it does and doesn't work. Again, every data source has a trade-off, so we want to work with you all to see where do you need that level of detail. And not every use case will require data every day. We're also looking into, less frequent offering, like a once every 5 days or other kinds of solutions that possibly could meet the needs. But the science behind it is it's been a peer-reviewed journal. It's been published that way, and so we are using methodologies that are pre-vetted in order to do this advanced data fusion with the different sources of data that we included: Landsat, Sentinel, PlanetScope.
Okay, thank you. Is there any question? If not, I would like to thank you one more time, Zara. I apologize that we wake up you so early.
It's my pleasure.
Thank you very much. And we had the presentation from private sector, we had presentation from researcher. Now will come the voice of European Commission. So please, Marie-Françoise, give the floor to Stefano, and Stefano, floor is yours.
Thank you very much, I'm very pleased to be here today and to be able to present what we have been doing recently. Okay, I see that you are sharing. Shall I share? No, what should I do? Okay. You are sharing actually my presentation. Is it correct? I mean, I can.
Oh, you can share this. You will have.
Oh yes, yes. I can share it, of course. I can share it. Can you see it now? Can you see my presentation?
Not yet. Now I see only you.
Okay, now I'm sharing something.
Yes. Yes, it's now. Thanks.
Okay, so now it works. Good. So this is. Let me try to minimize this. Okay. Okay, so this is my presentation. I'm going to talk about the Destination Earth and in particular some very valuable use cases dealing with agriculture. And let me start by introducing what is, Destination Earth, because I'm sure that not everybody is familiar with this new name. So, I mean, the background here is the European Green Deal. I think that you heard about the European Green Deal strategy. I mean, Europe is going to develop a real aggressive change in terms of economic development, and we are hoping to become the first carbon neutral continent in the next decade. So this is exactly the objective of this Green Deal, and of course, if we want to achieve this, we need to use the digitalization. So we need to use the recent digital transformation in terms of instruments, but also in terms of new paradigms and approaches. And here there are three main pillars, let's say. One, it is data, of course. I mean, we need data, we need to share data, we need good quality data, and we need the platform in order to access data. But then we need also what is called analytical methods and instruments. So basically machine learning, artificial intelligence, and so on. And in order to run this, we need also infrastructure. So, I mean, computing capacity. So these are the three areas that have been under, attention as far as the European Commission. And in particular, we want to use these recent developments in terms of digitalization in order to develop a very high precision digital model of our Earth. And this is exactly also present in the European strategy for data. In this case, the focus is on data. And here, the main concept is to establish what are called data spaces, common data spaces, covering different areas. One of them is agriculture, by the way, but there is also another one, which is the Green Deal. So in this strategy, it is foreseen the development of a Green Deal data space, and in particular, a couple of actions have been already identified in order to implement this data space, and they are Green Data for All and Destination Earth. And here we are. This is exactly what I'm going to cover today. So it is the flagship, let's say, in order to implement the Green Deal data space. And in this framework, the European Commission asked the Joint Research Center in order to support the leading DG, which is the DG Connect, in order to gather and analyze valuable policy use cases. So we started from needs, of course, in this case, policy needs, then developing a first system architecture. So how to, connect the existing assets at the European level. They must be operational assets because this is part of Digital Europe program. Money are coming from a Digital Europe program. as you may know, the Digital Europe program is different from, I mean, what used to be Horizon 2020 and the next Horizon Europe. In the case of Digital Europe, the technology readiness level must be very high. So we are considering operating systems and the capacity. And then finally, how to collect. And I mean, we collected and analyzed the ongoing activities at the member state level, but also beyond, because clearly the member states programs, national programs, are also very active in this area, and so we have also to establish synergies and not to do things. And so the Digital Earth aims at developing what are called the digital twins of the Earth. And here I just collected some, I'm sure, very well-known definition of digital twins. In particular, the first one is by W3C, and in our view, in the framework of Destination Earth, a digital twin is a workflow, let's say, where you connect one or more data streams to one or more analytical models. It is better if such models are data-driven and not process-driven, but it is not only limited to data-driven analytical models. And then, of course, we generate intelligence that is provided as feedback to the reality, so to the physical entities. Okay, and this circle must be maintained, so the physical entity and the digital entity are synchronized. And this is exactly the objective of the digital twins in Destination Earth. And so they can be defined also as a knowledge-based application addressing multiple policies use cases, because as I said, this starting point is policy use cases. So we interview the different policy DGs of the European Commission in order to start from valuable policy cases and then understand which of these digital twins can be developed. So now I will talk about the use cases investigated so far. We contacted, as I said, policy DGs as well as other relevant European stakeholders. So here we have ECM, WF, the European Environmental Agency, European Space Agency, EUMETSAT, Mercator Ocean, and of course the Joint Research Center. We ask our colleagues, starting from the policies point of view, which are the most used but also the most promising use cases in terms of advancing the current state of art by using the recent digital transformation capacities. And we collected about, actually exactly 30 use cases, and we clusterize according to more mature, less mature, and still to be, further developed use cases. And finally, we ensemble some of these use cases because they express quite common ground and they are synergetic. So we combine them in order to recognize two and more even digital twins. So as far as maturity now, we have two digital twins. As you can see, the first one is called Extreme Earth, in particular disaster risk management from extreme weather induced natural disasters, and the other one it is climate adaptation in terms of food and water supply security. But we have also, recognized a third twin, which is ocean modeling, and maybe others. There are also some other interesting use cases that can be used for other twins. And as far as agriculture, here there are three quite interesting use cases that we.
Ja, klar, das ist
Please, anybody, mute your microphone,
das ist
please.
zwar ein Teil des Pachtland, aber wenn das Pachtland fällt, bin ich schon.
Walter, please mute your microphone.
Was?
Walter?
Ja, ist wurscht, aber hinten, aber er hat bis hinten auf.
Walter?
Could we not have conversations while the presenter is presenting?
I have muted Walter.
Okay, thank you very much, Marie-Françoise. Okay, so here I present you three of the most mature use cases. And as you can see, there are climate change adaptation in agriculture in order to develop sustainable and effective adaptation strategies for agriculture. Second one is agriculture monitoring and the European, community policy for agriculture, in particular to establish a collaborative platform for the prioritization of CAP measures, and finally climate resilient rural and agriculture planning in order to support the climate resilient rural and agriculture planning. But if you look at some other of the displayed use cases, you can also spot, quite interesting cases also for agriculture, such as fires or, ecosystem preservation, etc. And just to give you a flavor of what a use cases is in terms of, description, this is a typical description. And as you can see at the bottom of the table here, the digital twin aspects and the so-called beyond the state of art aspect have been particularly considered, because as I said, Destination Earth is, aiming at developing twins and using these twins for implementing policy use cases, but also to advance, the current scientific state of art. And a part of the digital twin, of course, is also to develop a common infrastructure. It's called an horizontal infrastructure. And here are the main principles agreed about these infrastructure. So, I'm sure that you are familiar with most of these concepts. So, as I said, to contribute advancing the scientific state of art, adopt a policy / user-driven approach, introduce usability, flexibility, and evolvability by design, implement data model and computing resources sharing and benchmarking, and finally decouple what is called this horizontal scalable infrastructure and the set of pluggable digital twins that should be built on this horizontal infrastructure. And here, opportunities, but also challenges, of course, are coming in terms of scalability and the data dispersion, the co-design, the governance, in particular, not only the technological governance, but also the, of course, institutional governance, resource orientation, and multi-cloud. And this is a very, it is a oversimplified schema. So there is this horizontal infrastructure and enabling platform, including, of course, computing, data, artificial intelligence, machine learning, shared resources. Then on these, through, of course, APIs, a set of digital twins will be developed, and these digital twins, once more through APIs, will be used by one or more policy use cases. And in order to design, we have designed, there is a study and report about this infrastructure, and we establish a technological working group engaging ESA, ECM, WF, EUMETSAT, and of course G-Connect, the Joint Research Center, is leading this group. And the other outcomes of the study were the set of the use cases and recognize digital twins, and finally a study about what is going on in terms of member states, but also beyond Europe. So also what is the digital twin development situation in the US, Australia. And these results were presented, well, actually 10 days ago, or less than 10 days ago, to the member states, European Union member states, and we got quite positive feedbacks. And so we have also asked member states to provide more feedbacks. We, of course, interview them, but I'm sure that we miss something, so we also ask to provide feedbacks and inputs. And they will do it, of course. As I said, we are working with the, well, let's say, significant European infrastructure leaders, so ESA, ECM, WF, and EUMETSAT. Then, of course, other will come, in particular DIAS platforms, as well as Euro, HPC, etc. And we decided also as a follow-up of our infrastructure architecture to develop a proof of concept in order to demonstrate how we can connect the existing infrastructure of the stakeholders and develop a common, let's say, cloud-based APIs for developing digital twins. And this proof of concept is under development. And once more, the Joint Research Center is leading this effort. As I said, agriculture is very well represented in this use case, and the attention to the climate change impact on agriculture is one of the main concerns as far as policy. So this is actually why use cases and digital twins are so focused on this area. So Destination Earth is also the first development in terms of data space. So we are sure that what we will do will be also observed carefully by the other data spaces. And also, since we are connecting existing infrastructure, well, cloud-based infrastructure, of course, also in the area of multi-cloud, we think that we will provide some valuable example and input to the Cloud Federation activity envisaged by the European Strategy for Data. And that's it. Thank you for your attention.
Thank you, Stefano, for your very interesting presentation. Is there any question?
Yes. Which data are you targeting to populate this agricultural data space?
Yeah, thank you. Well, I mean, clearly there are many possible European data sources existing, of course, data sources, because once more we have to build on existing resources and capacity developed at an operational level. So clearly there are several. We started collecting inputs from ESA, ECM, WF, and EUMETSAT, but we also engage, of course, European environmental agency. So time being, we have worked in order to connect Sentinel and Inspire, of course, data into classic, let's say. And then we will engage, as I said, more and more the European Union member states, and they also provided us with some interesting inputs. But this is really an ongoing, development. So the idea here is to have a living platform in terms of a platform where existing, but also next coming operational systems and resources such as data streams, but also analytical models can be plugged in and can be added, you know. So, I mean, this is really, I mean, this is the first time, I must say, that we present this outside the Commission and the member states. So if you also have some inputs, I mean, please contact me or contact us. Max Graglia is also the other, you know, colleague deeply engaged here, and you can you know, propose or you can provide us with valuable inputs. Of course, I didn't mention, but the 3 use cases that I presented have been developed by a team of you know, experts coming from European Commission, ECMWF, etc. And so, I mean, they already proposed a set of data streams. But as I said, this is a real, you know, living effort. We call it an ecosystem, because this must grow in time and this must be open in order to connect what is useful for implementing the European Common Green Deal strategy.
Okay, any other question? If not, I have number. Yes, first, for the future, how will be the relation with INSPIRE directive? Is it will run parallelly with INSPIRE, or will in some way extend or replace INSPIRE? What is the intention?
Well, this is a very good question. I know that you are expert in that. So, yeah, indeed. I mean, as far as the future of INSPIRE, the Joint Research Center is very much engaged with the other action, you know, that I mentioned for the Green Deal, which is called Green Deal for All. So we are thinking to evolve INSPIRE with the Green Deal for All. And so the question is how we will connect a Green Deal for All and you know, Destination Earth. And of course, and since we are engaged in both, the connection in terms of you know, design and in terms of synergy is easy. In terms of technological development, as I said, the Destination Earth is a sort of let's say scouting action. So what we will develop in the Destination Earth, especially for the horizontal platform, should be, you know, reused, or at least should be considered as much as possible for reusability also by the other actions, you know. But clearly, I mean, as far as data, as far as twins, then this is a completely different stories, because the platform is conceived to support many different twins and several diverse use cases and therefore applications. And I'm sure that, you know, Green Deal for All will contribute to this Green Deal data space and with you know, unique and valuable data. And so, I mean, they will also provide unique and valuable use cases, I'm sure. And so the real challenge is how to support them. So we will add these valuable use cases to the 30 already collected from our colleagues.
I have other question. As I am here today representing mainly L4 Agri team. I don't know, probably you heard about this project, and we prepared some analysis and recommendation for future as observation. What I see as one from the most important things for the future with Green Deal, there will be big push on the farmers. And probably, or our recommendation is that in the future we need some type of public-private partnership where farmers will also receive information, because with all this push, farmers will be not able to pay all this type of the services analysis, and they will have no skills. And there is some need of cooperation of private and public sector in this, and I think that it will be good for already from the beginning to involve in such cooperation also this view of this farming sector.
Indeed, indeed. I mean, I fully share your comment here. Let me say that this Destination Earth action is a multi-year action. So, I mean, in the next year, we will start with the very first step, but several steps are already considered. So, as far as the first step, we thought to start with the so-called European operating, infrastructure. So, as I said, ESA, ECMWF, EUMETSAT, and then of course the DSEs. But then of course we also engage member states, and now we are thinking how to engage also the private sector, and in particular the commercial sector, because these are the main stakeholders that we see. But since it is a very complex and a very bold action, we had to start from let's say the most the most reasonable end, and the most reasonable end, of course, for us was to start from the public European infrastructure. But soon, of course, we will also reach out to the other stakeholders. And as I said, we already started, because 7 days ago we presented the studies to the member states. So I'm sure that they will also inform the public, but also the private sector. But certainly we have to do more, and we have to also engage directly, the private sector, and we will do that. We are going to do that.
Stefano, there is one thing I would like, because on Friday there is organized some common meeting between EUFOR Agri and the staff from the Commission from different DGs. I don't see you or Max on the list. If you will be available on Friday morning, I think it is from 9 till 12, I can ask coordinator or project officer to invite also you to the discussion, because I think that it will be very useful to share our ideas with the ideas what you are now preparing for digital twins.
Yeah. Well, I mean, thank you for this kind invitation. If you can please send me a message, so I will check with my agenda. Max is on holiday, and he will be back on Monday, so I don't think that Max will be available anyway. I mean,
okay,
I can please send a message to both of us. Yeah, you put also Max in copy, but I just wanted to anticipate that Max, lucky man, is on holiday.
Okay,
maybe I would like to comment a little bit. Possible now?
Yes.
Okay. So the key question, we are a rather powerful public and private group out of several countries who prepare something in the moment. We have forgotten that the ecology in agriculture and forestry is a valuable product. We just had economic output, hectare size, and ton of productivity. All the positive elements that the ecology is producing had no value. And this is something we have urgent to change, and there must be a responsibility. But the responsibility for this value that every user is using, every customer in whole Europe, the whole population is using water, nice landscape, good air, recommendation and all these positive things from the nature. And as long as only Adam and Eva have been here, we had enough forested agriculture area. But now we have to optimize the whole thing. And this has to get a value, because otherwise we always compete billions against a nice tree. It will lose. And it's not correct. And we did now with 2 University Institute a fantastic new tool. When we have the right information, we can also evaluate the damages, evaluate the positive elements of the nature. As long as we don't evaluate them, we will be wrong. Nature will be a loser.
No,
So
absolutely.
we are coming to the end, please.
Yes, I think we are going to close the session. Just to address the comment from Walter. I'm working to bring some people from biodiversity at OGC, because I think it's a domain that would be really worth to bring. It's transversal to many activities, and I'm happy to see that you are sharing my position. I think it would be really nice to have these people. It's transversal to many.
I do it since 30 years. It was not always easy. It's sometimes hard, but now we are so far.
I'm sure it is super complex, and it is one of the.
No, it's not complex. Today, for me, it's easy.
Oh well,
It's not
I'm
complex when you know it.
Okay, well, I would like to thank you very much, because we have gone over the hour, and so
Thank you
invite
also very much.
to join the ERMIT now, which is also implemented and organized by OGC to help you follow up the discussions and share your view in a more informal context.
No problem.
Thank you.
Always. Thank you very much for all this.
Okay, I would like to thanks to all presenters today. I think that program for me was very interesting. We had number of very good presentation. I would like also thanks to OGC that they give us the possibility for this 3-hour meeting, yes, to discuss this issue. I hope that we will continue in the discussion about agriculture, because I see this agriculture as a very important topic, and I will be very, very happy to continue in our cooperation. So one more time, thanks to all, also to people who listened this presentation. I hope that you don't lose the time, that it was also interesting for you. Thank you.
Thank you.
Thank you very much.
Bye.
Thank you. Bye.
Thank you. Bye.